Good morning. I am Suni, Assistant Professor, Department of Mathematics, Rogini College of Engineering and Technology. Now I am going to teach the topic Contour Integration Type 3 for the course MA 8251 Engineering Mathematics 2. The course outcome is after completing the course, the student is able to evaluate real integral. For type 3, the integrals of the form integral minus infinity to plus infinity f of x by g of x sin nx dx or integral minus infinity to plus infinity f of x by g of x cos nx dx. To evaluate this integral, we write sin nx and cos nx in terms of e power I nx. Thus, our integral becomes minus infinity to plus infinity f of x by g of x e power I nx dx. It is equal to integral over c f of z by g of z into e power I n z dz, where c is the closed curve as in type 2, and finally we equate imaginary part or real part accordingly to get the required integral. We have to solve one problem. Evaluate integral 0 to infinity cos mx by x square plus a square dx, where a greater than 0 and m greater than 0. Now here the integrand contains x and cos mx. So clearly it is type 3. So we give the substitution x as z, dx as dz, and cos mx is real part of e power I mx. Now our integral limit should be minus infinity to plus infinity, but here in the question it is 0 to infinity. So 0 to infinity is nothing but half of minus infinity to plus infinity. So we write 0 to infinity cos mx by x square plus a square dx as 1 by 2 into integral minus infinity to plus infinity real part of e power I mx divided by x square plus a square dx. Now we replace x by z. So we get 1 by 2 into integral over c real part of e power I m z by z square plus a square dz, where c is the upper semicircle. This may be written as real part divided by 2 integral over c f of z dz, where f of z equal to the integrand, that is e power I m z divided by z square plus a square. Now we want to find the value of this integral. For that, first we find out the residue. For that we set the denominator value as 0, that is z square plus a square value was 0. From this z square equal to minus a square and z value was plus or minus ai. So we get two poles ai and minus ai. Here we consider only the positive values because the circle is the positive upper half circle. So we consider the aa pole is inside and minus aa pole is outside. So we find the residue for the inside pole ai. Now residue of f of z at z equal to ai is obtained as limit z tends to ai z minus ai f of z. So in the place of f of z we substitute e power I m z divided by z plus ai into z minus ai. Then z minus ai cancel. Now give z value as ai. We get e power I m ai divided by ai plus ai to ai. Now we get that e power minus ma divided by 2ai. Now by Cauchy residue theorem, the value of integral f of integral over c f of z dz equal to 2 pi I into sum of residues. Here we got only one residue, so we substitute the value of residue here. So we get 2 pi I into e power minus ma divided by 2ai. Then 2i cancel, we get pi by a into e power minus ma. Now substitute the values in equation 1. We get equation 1 implies integral 0 to infinity cos mx divided by x square plus a square dx as real part divided by 2 into pi e power minus ma divided by a The whole terms are real part, so we write the whole term. That is pi by 2a into e power minus m. Some important questions in this topic are. Thank you.